Okay, good morning, class. All right. For those who already here, can you please click the link? Okay. I will try to use the peer deck. Okay, for our class. Okay. So I want to see whether it's functioning or not because just now when I use for 4M, there's a few problem. Okay. So I want to test whether it's okay. If it's okay, then we will use this one. So for this one, I can get your response, right? So far here only like 10 students, so I wait for 6 more. Weekend that Tava joined the class this morning?
No,
No. Okay, so mean I'm waiting like 4 more.
it's one more.
One more. Yeah,
Yeah.
I mean at the my slide here. This one, yeah, five.
Oh, okay.
So please only 11 students, okay, connected. I need to wait like 4 more. 3 more. Still cannot connected. Do you have a problem? Maybe your line. Yeah, it's like that. We can. We're still not here. 4 more students. Please join. No, we cannot start our class. Yes. 1 minute, share my internet is slow. Okay. Okay, while I'm waiting for your friends, okay, so I see some response here. Actually, we don't know who is the response, so it's okay. You can just write what is your opinion. It's complicated to say, but it's really interesting. I must it about the universe and things happening around us. I think it's half okay, half art. Easy, you just have to relate. Yeah, very good. Not so easy, not so hard. It's fine to me. Well, relatively, but I don't like physics. Well, okay. Hard, half easy, half hard, really hard, really hard. Okay. Okay, so hard. Okay. Okay. So I think all of you already response. Okay. Hard, hard. Yeah. Since yeah. 4M also say the same. Hard. cannot remember formula, too many formula, right? Hmm. Okay. So never mind. Right. So it's okay. So let's see after we finish. We still have one more chapter. So after that, maybe if we do more exercise, maybe it will be much easier for you, right? Okay. So it's okay. So let's see the next slide. Right. So I want you to click on the link. So this one is actually to see how much do you know about wave actually. Okay. Right. So I'm waiting for 13 more.
Teacher, can send the link again.
Link. I thought the link is at the below here. You can see here the student browser there. You can see quizzes, right? Can you see? No. At the below on your left, okay, on your left, at the student browser here, there you will put the link there. So you just click the link.
No, teacher, she left and joined back, so the chat box already deleted for her.
Oh, you mean the?
Because my link was bad, so I left and joined again.
Oh, okay. Wait for a moment.
Uh, yeah,
Yeah,
teacher,
this
for
one.
some reason I'm
Yes.
not directed to this page.
Oh, then
I
where
am
is?
peer Dex page. I don't know why.
It ask you to put your name, is it? Are you joining late just now? Is it?
No, teacher, I'm already in that place, and then I press the link, and then I'm directed to the peer Dex main page and not quizzes.
Oh, really? Others, are you having a problem? I try to join. Oh, yeah, mine also. Then others, how you? Because I think if you see, right, if you see on your right, I think it's already, you already logged in, right? My screen become like this because I see your screen also. You see like this? I send you in the group. Yeah. Can you see in the group? Then you just write your name, I think, and then you just press start. Is it okay? 12 already. Because I think they are already separate, right? Like this one is the presentation, the other one is for quizzes. So that on the left, on the right, you just write your quizzes name. Uh, why yours is different? Oh, yeah, I see yours. Okay, never mind. I will give you the link here.
Teacher, I joined from quizzes.
Okay. You have a code, right?
Yes, teacher.
Okay. I send you the link here. Okay. For those who cannot join using the peer deck, okay, you can join using the link I gave in the chat box in the Google Meet. So we're still waiting for 3 people here. Or maybe we can just start and later they can, okay, 2 more. One more? Okay, good.
Teacher,
Yes.
I think when you change your slide, our
Oh,
slide also changed already.
okay, sorry.
It's okay, teacher.
I thought it will not affect. I'm sorry. It's okay if you got it wrong because we still didn't learn, right? Okay, I give like 2 more minutes. Done. Okay. So I give you like still like 3 people. I think didn't finish yet. So only Lakshmi left. Okay, all done. Right, so Vikan number 1, Avinash number 2, Eugene number 3. Okay, very good. Okay, so it's okay if you got wrong. Then after this, I will give you the next test. So see whether you can answer it, okay, better or not. Okay, so we continue to our presentation. Alright, so here is said here, what is wave? Okay, so let's say if you drop a stone, okay, into the water, right? What do you see? Okay, so actually there's a video here, but I'm not sure why it cannot play, right? Okay, so I just let just see at the wait, I present first. Yeah, I already present, right? So let's see the PowerPoint, okay, at the Google Meet there. Yeah, I already share my screen. So here you can see the video. So the video we will see here, okay, until I figure out how to add the video, okay, inside the peer deck. Okay. So let's see what will happen if we drop a stone, okay, into the water. Right. Okay. So what do you see here? Okay, what do you see here?
Ripples of water when the stone falls into the water.
Okay, ripples of water. Okay, and what is the direction? What's the direction of movement?
Away from the point where the rock falls into the water.
Yeah, okay. So it will move away or it move upward, right? From the center of the circular wave here. Okay. So you can see here it will move, right? So wait, I rewind it. Okay, so it move upward, right? So it move upward. So this is actually a wave, okay, but this one is a wave. So there's many type of wave, okay. We have a water wave, we have a light wave, okay, and also we there's a lot of kind of wave, but this one we will learn sound wave, light wave, and water wave. Okay, for this chapter, sound wave, light wave, and water wave. Okay. Okay, for this one, they use a rope. Okay, they use a rope to produce a wave, and for this one, they use a slinky spring. Okay, to produce a wave. Okay, and this one they use a ripple tank, right, to produce a water wave, and this one they use a turning fork. Okay, to produce the sound wave. Okay, so mostly all of these they use a vibration. Okay, they use a vibration. Okay, to produce a wave. Okay. Okay, so let's see the next slide. Okay, so this one I think they don't have a video. See, so that's why I cannot play here. Supposedly to be there's answer here, right? Right, so means we have to use a PowerPoint. Okay, so it's not working. Sorry. Okay, so let's see for using the PowerPoint. Okay, so means later I know that for papier that I can use for the question only. Okay, so let's say if we do a question exercise, we can use a peer deck, right? Okay, so let's move on to the using the PowerPoint. So you can leave the presentation. Okay, the one that I give, you can leave the peer deck. Okay. So the first one is activity one, right? So this one is to study a vibration of the dipper of a ripple tank and the vibration of the turning fork. Okay. So this is attach a dipper until it is spherical end and touch the surface of water. So some of you must wonder why is it a ripple tank? Okay, what is actually a ripple tank? Okay, so let's see one video to show a ripple tank here. Okay, so this is actually a ripple tank. It's fast. Okay. So there's a lot of type of ripple tank. So actually in school we have the rectangle shape one, but this one is a circle one. And you can see later, right? Later I will explain more. Right. So you can see there is a light here, okay? And this is the dipper, okay? So this is actually a dipper here, right? And you can see there is a pepper, white pepper here. So what is the function of the white pepper here? So this is actually to see the shape of the wave, okay? Whether it's circular, right? What happened when it passed through it passed through an obstacle, it passed through a gap, okay? So all that you will have to see on the white paper. So there's a light here. So the light we goes to the water wave here, and we goes to the here. So this is actually act like a screen. Okay, but later at school actually we got a white screen there, so you can see at the white screen what is actually happened during the diffraction. Okay, so that one you will learn later. Okay, so I just want you to know this is actually the ripple tank, and you can see this is a dipper here. So the dipper will vibrate, right? So when you vibrate into the water here, right? When you vibrate into the water here, that will produce the water wave. Okay, so let's see. So you can see this is a circular wave, right? So they produce the circular wave, and you can see the wave it move upward from the center. So this is the center of the wave. You can see it move upward, right? And this is a, let's say this is only one dipper that vibrate into the water. So it will produce the circular water wave, just like when you throw a stone, okay, into the water. Okay, so this is called as ripple tank. Right, so let's move on. Okay. So it says here, right? So attach a dipper until it's spherical and touches the surface of water, and then you have to observe the surface of water when the motor does not vibrate. So of course, when the motor does not vibrate, the dipper also will not vibrate. So the water will be calm. Okay. And what happened then? The motor vibrate. So of course, the dipper also will be vibrate. So when it vibrate, it will move up and down. Okay, so it move up and down. Okay, for the number 2, it says here, let's say you hold a turning fork, right? And you can hear the sound produced by the turning fork. If the turning fork is not vibrate, okay, of course you cannot hear any sound. Okay, you have to remember that actually sound is produced by the vibration. So let's say I'm talking right now, right? So I can see in my throat there, I can feel there's a vibration. Okay, so the vibration. So let's say if I talking right now, so there's a air around, the molecule air around the surrounding here, right? So when I talk, the molecule also will vibrate. So when it vibrate, it will transfer the energy. When it vibrate, it will collide with another molecule, then it will transfer the energy to that molecule, and that molecule also will vibrate, and then it will collide with another molecule and transfer energy, so until it reach your ears, right? So your ears, there's an eardrum, right? So your eardrum also will vibrate, and then after that you already know it will transfer the sound energy to the kinetic vibration energy to the sound energy. So that one, your brain will translate, right, what the teacher say. So that's the what I want to show. It mean the vibration, okay, with the sound is produced by the vibration of the air molecule. So that's why sound needs a medium. Okay, so it cannot travel through a vacuum, it needs the air molecule to vibrate. Okay, so here they say when for the turning fork, when it vibrate, okay, you can hear the sound, right? So wave can be produced by an oscillating or the vibrating system. Okay, so the example here, we use the oscillation of the dipper, okay, on the water wave. Okay, it will produce when the dipper is vibrate, you can produce the water wave. Okay, for the turning fork, when it vibrate, it will produce the sound wave. Okay, so this is the water wave and this is the sound wave. Okay, so here you can see the video here. So this is actually what? This is actually a tsunami. Okay. So tsunami, the water wave carries energy too. So observe the effect of energy carried by the water wave. Right. So this is the tsunami, I think, at the Indonesia, right? Okay, and then after that it hit Japan too. Okay. So the water wave carries energy, so that's why that tsunami happened. Okay, because it carries energy. Okay, so what is actually wave? Okay, so you can see just now we already said that wave carries energy. Okay, so what is wave? Wave is actually a process of transferring energy from one location to another, which is produced by oscillating or vibrating system. Okay, so just now like I explained to you, okay, how does the sound energy travel, right? So it travel, it transfer the energy, right? Remember I said just now, okay, when I talk, okay, the air molecule that surrounded me also will be vibrate, all right? So when it vibrate, okay, it will collide with another molecule, and then when it collide, it will transfer the energy to that molecule, and then that molecule also will vibrate, and then it will collide with another molecule, then transfer the energy, okay, then it vibrates, so it will happen until it reach the location, to another location, right? So me it transfer the energy, so every time it vibrate, okay, it collide, it transfer energy. So actually wave is what? Wave is the process of transferring energy, okay, from one location to another location, okay, and is produced by the oscillating of the vibrating system. Okay, so it must be oscillate and also it must be vibrate. Okay, so wave is a transfer of energy. Remember, it's transfer of energy, okay, not transfer of matter. Okay, the matter will not transfer. So later we will see a video to show that actually the matter is not transferred, only the energy that will be transferred. Okay, okay, so this is the video. So you can see the water wave is produced like when your dipper is vibrate. Okay, so alright. So you can see here the water move up and down like that. Right? Okay, so let me see it move up and down. Okay. So it move up and down. Okay, and you can see here the water travel from the direction of the propagation of the wave. Okay, it travel from the right to left. Okay, so let's see again. It's because this one is too fast, right? So it travel from here to here. Okay, okay, from right to left, right? So means from right to left. So direction of propagation is actually where does the direction of the wave travel. So this one from the left to right. Okay. So and then I put a leaf here. Okay. So leaf is actually it acts like a wave particle. Okay. So it acts like a wave particle. So as you can see here, when it vibrates, does the leaf move? Okay, the leaf will not move, right? You only move up and down, but it doesn't move in the same way as the direction of the propagation. It just move up and down, but it will stay at the initial position. Okay, right? So here, what do you see on the water surface just now? Okay, when the dipper is vibrate, you produce the water wave, right? And then what is the direction of the propagation? I already explained and we already see in the video. You can see it travel from the from the right to the left, right? And then here, it says here, let's say the left represent a water particle. So how does the water particle move? So it can only move up and down, okay, but it will not move with the same way as the direction of the propagation. It will just stay at the initial position, but it just move up and down like that. Okay, so the water particle move up and down. Okay, so you can see here what is the, we can do a conclusion here. We can see that actually the wave only transferred energy. Okay, but the matter of the wave particle will stay at the initial position and it just move up and down like that, right? Okay, wave transfer energy without transferring matter. So as the wave passes by, does the leaf move together with the wave? Does it move? Does it move together with the wave?
No.
No. Okay. So this one, what you can say. So actually, wave only transferred what?
Energy.
Yes, it's only transferred energy. Okay. So no, the leaf does not move together with the wave. Instead, it moves up and down about its initial position. Okay, so wave transfer energy as they move along with the water particle. Okay, however, the wave do not carry the water particles along with them. Only energy that being transferred. Okay, so are you clear about this one? Do you have anything to ask?
No, sir.
No, no. Everyone, are you okay? Trisha, Farah, Asher, Avinash, Sajib. Okay,
Okay, teacher.
okay, right. So yeah, wave transfer energy without transferring matter. So how does the wave transfer energy? So just now we see when you drop a stone, right? So energy from the stone, okay, it been transferred to the water. Okay. So here when a stone is dropped into a pond, okay, so water wave are produced. So the energy of the stone is converted to wave. Okay, so the water will propagate on the surface of the water. So the direction of the propagation of the water wave is from the left to the right. So here, let's say if you drop a stone here, so it will move from here to here. Okay, from here to here. Okay, from the left to the right. Okay, so the cloud is represent what? Anyone knows? The cloud represent the
Matter.
yeah
Water
the
particles.
water particles. Okay, it's produce the water particles. You can say it's actually represent the particles, particles matricles. It's okay, right? So here the cloud does not move together with the wave, so instead it move up and down only about its initial position. So what is transferred by wave is actually energy. Okay, so only energy that be transferred. Okay, so for this one, to investigate the propagation of wave as energy transferred. So let's say you have a slinky spring here and you tie a ribbon, okay, at the slinky spring. Okay, so here there are two ends, right? So one student held the end A and another one as end B. So the end B, it will be at fixed position. It will not move. Okay, only end A that we rotate. Okay, that we move up and down like this. Okay. So this one you have to observe what will happen to the movement of the slinky spring and the movement of the ribbon. So anyone want to try what will happen to the movement of the slinky spring and what will happen to the movement of the ribbon? What will happen to the movement of the wave? Okay, so whether to what, left to right or right to left. So when it oscillate from below and up and down like this. Okay, so what is the direction of the propagation? Actually, that's what you want to ask. Whether to left to right to left.
Left to right.
Okay, from left to right, correct? Okay, how about the movement of the ribbon? Is it stationary there or is it moving?
It moves up and down.
Okay, very good. It move up and down, but it will stay at the initial position. Okay, very good. Okay, so the next one it asks you what is the felt by the people at NB after the slinky spring is moved from side to side. Okay, so actually what the people at the NB will feel? It will feel what?
The hand will move together with the slinky spring.
The hair will move together. All right. Any other answer? Maybe you want to try. Any other answer than that?
They'll feel the vibration.
Yes, very good, Janet. Okay, you will feel the vibration. Okay, so you will feel the vibration of the spring. Okay, so what is the direction of the energy transfer along the spring? So this one Kirtiga already answer, is from left to the right. Okay, and describe the movement. Also Kirtiga already answer, this one it move up and down, but it will stay at its initial position. Okay. Okay, so number one, movement of wave from NA to NB transfer energy from A to B. Okay, so the ribbon does not move, okay, in the direction in which energy is transferred by the wave. Okay, only energy be transferred, but the ribbon will stay there, but only move up and down. Okay, so the conclusion here, waves are produced when the medium vibrates at the fixed position. Okay, so the wave are produced when the medium vibrates at a fixed position. So mean if you want to produce a wave, okay, you have to vibrate the particle. Okay, and the propagation of the wave transfer energy from one place to another without transferring the matter of the medium. So this one we already discussed. Okay, we only transfer the energy but not the matter of the particle. Okay, not the water particle. Okay, so let's say we have a drum here, right? Okay. Okay. So this one is actually what happened to the flame. Can someone explain to me? Okay. So actually for this one, okay, when the drum is vibrate, right? So the air molecule that surround the drum here also will be vibrate. Okay, so it will collide, okay, with another molecule, okay, and then the molecule also vibrate. Then after that, it will make the flame become flickers. Okay. So actually sound is a form of energy, right? What happened to the flame when the hand beat the drum and why? So here the flame will flick. So sound wave transfer energy from the vibrating drum to a candle flame, so causing the flame to be flicker. So actually you have to remember is actually the air molecule that will vibrate. Okay, that will vibrate. So as the wave passes through the air, do the air particle move along with the wave? Okay, so the answer of course no. Only the air particle only will vibrate at their initial position, but only will be transferred the energy to another particle. Okay, so it will just stay like that. Okay, later we will see the video, right? So it will stay like that. Okay, but it will vibrate. Then when it vibrate, it will collide with another one, right? So collide with another air molecule, then the another molecule have energy now, then it will vibrate, then collide with another molecule. But it will just stay at there at the initial position. Okay, it just move, okay, to transfer the energy, but it will stay at the initial position. Okay, so this is the video to show. Okay, see it collide, okay, and transfer the energy. Okay, so that's what happened. Okay, so the air particle transfer energy to the next particle but stay about its initial position. So as the wave passes through the air, the energy is transferred, okay, without the transferring of matter. Okay, so let's see for the activity 2. Okay, so it says here to investigate the propagation of wave as energy transfer. So they say if I put a candle, okay, in front of the speaker, so you have to observe the flame when the speaker produce sound. Okay, so here let's see the video. Okay, so you can see the flame move right and left, right? So this one that you can see the flame is flicker. Okay, so how does the flame receive energy to move? Okay, so the energy, the sound wave transfer energy from the speaker to the candle flame. So between this there has a air molecule. So when the sound produce, the air molecule, okay, between the speaker and the candle also is become vibrate, right? So when it vibrate, it will transfer the energy to the next air particle. Then after that, it will goes to the flame, and then the flame will be flickers or move right or left. Okay. So when energy is transferred by a wave from vibrating sources to a distant receiver, so there is no transfer of matter between the 2 points. Okay. So energy transfer through sea wave motion can be huge. Okay. So for example, during tsunami, the energy carried by water wave from the sea can cause great damage to the surroundings. So most of energy comes from the winds blowing across the surface of the sea. Okay, so that's why you can see if the tsunami, it can destroy even a building also. Okay, so this is because they carry the large energy, the huge energy that come from the wind. Okay, that across the surface of the sea. Okay, you can see the tsunami effect. So this is before and this is after, right? So any question you want to ask about the wave? What is wave actually? How does wave transfer energy? You have anything to ask, teacher? Before we goes to the type of wave.
No, sure.
No. So alright, you are clear?
All okay.
Okay, very good. Okay, so let's move right to the next one. Okay, the type of wave. Okay, so wave profile. So the shape of the slinky spring as the wave propagate through it. Okay, so for this one, it's actually it move up and down. Okay, so it move up and down. So for that, this is for slinky spring. Okay, but for the water wave, we already discussed it move upward like that. Okay, so that is the wave profile. Okay, so the shape of the wave. Okay, so this one it move up and down, and also at the same time it move to the right. Okay, and for this one, the water wave it move outward like that. Okay, so that is the wave profile. So the shape of the sinking spring as the wave propagate through it. Okay. Okay, so there are two types of wave, the progressive wave and the stationary wave. Okay, for the progressive wave, okay, the wave profile that propagates with time along the direction of the propagation of wave. So you can see when you throw the water, when you throw a stone into the water, right? So you can see the movement of the water, right? It move upward. So that one is a progressive wave, means it move along the time. Okay, but this one for the stationary wave, okay, there will not move, it will stay, it's not does not propagate with time. Okay, this is the example. So that's a guitar. Okay, so a guitar it will just vibrate on the same point, right? Okay, but this one it will for the water, you can see a movement, that a movement of wave, okay, throughout the time. But this one for the stationary wave, it just stay there. Okay, so it will not move. Okay, so this one we call it as a stationary wave, and this one is a progressive wave. Okay, there's a movement of the wave, you can see it move outward. Okay, so that is a progressive wave. So this is the example, water wave is a progressive wave, while the stationary wave, you play a guitar, you can see it's only vibrate, okay, at the same place. Okay, even the time pass by, it just vibrate at the same place. So that one we call it as a stationary wave. Okay, the mechanical wave and also the electromagnetic wave. Okay, so the mechanical wave, it requires a medium. Okay, so let's say just now I give you the example. Okay, like sound wave. Okay, like the sound wave, you need a medium. Okay, so that is a mechanical wave. Okay, you need a medium to transfer. If there is no air molecule, so means there is no sound that can be transferred. Okay, so that's why they say in the outer space, okay, so there is no air, right? So you cannot just talk like that, people will not hear you because there's no medium, so you need a medium. So mechanical waves, a medium to transfer, requires a medium to transfer energy from one point to another point, and it's made up of vibrating particle of medium. So I already told you just now, like sound wave, they need a molecule air, and the air molecule need to vibrate so it can collide, it can transfer the energy to a next air particle, then the next air particle also will vibrate, then transfer the energy to the next particle, right? So it made up of vibrating particles. Okay, the vibrating is actually the process of transferring the energy. That's the process how to transfer the energy to another medium. Okay, so the example is the water wave, right? Sound wave, okay? Seismic wave on the surface of the earth, okay, are example of the mechanical wave. Okay, how about the electromagnetic wave? So electromagnetic wave is just like the sunlight. Okay, so the sunlight actually, how does the sun can travel from outer space, then it can go to the earth, right? Can enter the earth. So that one, the electromagnetic, that is the example of the electromagnetic wave. Okay, light wave. Okay, so light wave, they do not need a medium. Okay, so it can to be transferred. So this is the example of the electromagnetic wave. Okay, so it does not need a medium to be transferred. Okay, and also they got the same velocity as the light velocity. So what is the light velocity? So the light velocity is 3 times 10 power of 6, I think. Okay, ms negative 1. So that is actually the velocity of light. Okay, so it made up for oscillating. Okay, electromagnet is actually the made up from the electric, okay, and the magnetic fields, okay, that is perpendicular to each other. Okay, so that produce the electromagnetic wave. Okay, and the example is the radio wave, light waves, and the gamma rays. Gamma rays is actually one of the radioactive rays. Okay, so that is an example of the electromagnetic wave. Okay, so I hope you already know the difference. The difference is actually the mechanical wave, they need a medium, while the electromagnetic wave, they don't need a medium to be transferred. Okay, while the mechanical wave, they need a vibration, okay, to transfer the energy. While the electromagnetic wave, okay, they are made up from the electric and the magnetic fields, okay, that are perpendicular to each other. Okay, so that we call it as an electromagnetic wave. Okay, so the example, okay, for the mechanical wave, water wave, sound wave, right, seismic wave, so electromagnetic waves such as radio wave, light wave, gamma rays. Okay, so that's a lot actually. Okay, so later we will learn electromagnetic wave. We will learn on the end, I think, chapter 5. Okay, so that's one part of the for the electromagnetic wave only. Okay, so far anything you want to you want to ask? No. Are you clear? Is it I'm too fast?
Clear, sir.
Okay. Others? Only weekend okay. Others?
Okay.
Okay. How? Why sound so weak? Okay. Are you sick?
No, teacher.
Teacher still very, like excited to teach. Okay, teacher. Okay, teacher. Ah. Oh. Oh, you already got your vaccine. Okay, so I'm already okay now. All right. So next, okay. So just now we only there's two type of wave, the one the progressive wave and the stationary wave, right? So actually there are another. We can divide the wave into two other types. Okay, that is a longitudinal wave and also the transverse wave. Okay. Okay, longitudinal wave and the transverse wave. Okay. So let's see the video here. So actually for the wave, there's a lot of video for you to see because that thing you cannot see, right? You cannot see a wave, okay, in our real life. So we have to see a lot of video. So to make you more understand. So this is a slinky spring, okay? Okay, all right. So this is called as a longitudinal wave. Okay, longitudinal wave. So I will explain. All right. So you can see this is the compression part. Okay, so there's a compression part, right? And this is a rarefaction part. Okay, so from here to here, okay, maybe I can write that. So this is called as a compression. Okay, and this is called as a rarefaction. Okay, so this is called as a longitudinal wave. Okay, longitudinal wave. And the example of the longitudinal wave is sound wave. Okay, so this is the example of the longitudinal wave. And you can see the direction of the propagation, it moves from the left to the right, right? You see the video just now, it moved from the left to the right. Okay, and also it's actually same as the way that you push the slinky spring, right? So that one is become parallel. So this is the longitudinal wave. Okay, so let's see. Okay, so you can see here the blue dot here is not moving, right? So the direction of the propagation, it moved to the from left to the right. You can see it's just like past the energy here, right? So it produced the one part is the compression and one part is the rarefaction. Okay, but the blue dot is still not moving. Okay, so we know that it's only transfer the energy. Okay, so here the blue dot represent a particle in the spring. What is the direction of the propagation of the wave? So the direction of the propagation, as I told you just now, it moved from the left to the right. So what is the direction of the vibration of the spring particle? So it's just same, right? It so move to the left, from the left to the right. Okay, so here it says here the wave propagates to the right and the spring particle vibrates back and forth. Okay, so here it's the same, right? So it's parallel to each other. So what can you say about the direction of the vibration of the particle in relation to direction of the propagation of wave? So we call it they are parallel to each other. Okay. So the direction of the vibration also you push it to the right, right? So then the direction of propagation also to the right. Okay, from the right to the left. Okay. And also at the same time you give the vibration also from the right to the left. So now if on the same way, right? So it will become parallel. So they are parallel to each other. So this one we call it as a longitudinal wave. Okay. So what does it mean by longitudinal wave? So this one you have to remember longitudinal wave. So the wave, which is the direction of the vibration of particle in medium, is parallel to the direction of the propagation of the wave. Okay, so this is called a longitudinal wave. Okay, direction of vibration of particle in the medium is parallel to the direction of propagation of the wave. So you have to remember it must be parallel. Okay, longitudinal. Okay, so this one. Okay, so this one it move up and down, right? The direction of the vibration it move up and down. But you can see here the wave it move from right to left. Sorry, from the left to the right. Okay, so it like making a perpendicular. Okay, the direction of the vibration you move it up and down. Okay, Why the direction of the propagation of the wave, it move from the left to the right. Okay. So this one we call it as a transverse wave. Okay. So transverse wave, right? And then you can see the direction of propagation is from the left to the right, and the direction of a vibration it move up and down. So what is the example here? So the example is the water wave. Okay, water wave. So this is the transverse, and also electromagnetic wave, also transverse wave. Okay. Alright, so the red dot represent a particle in the spin. What is the direction of the propagation of the wave? What is the direction of the propagation of vibration of the spin particle? So it will move, okay, to the right, and the spin particle vibrates up and down. Okay. So what can you see about the direction of the particle in the relation to the direction of the particle of propagation of wave? Okay. So this one is a perpendicular to each other. So it says here direction of vibration, you move up and down, right? The slinky spring. Okay. But you can see here the movement of the spring, the direction of the propagation of wave, it moves from the left to the right. So it's like making a 90 degrees. Okay. So 90 degrees means perpendicular. Okay, so perpendicular means this we call as a transverse wave. Okay, so a wave in which direction of the vibration of particle in medium is a perpendicular to the direction of the propagation of wave is called as a transverse wave. Okay, just remember the same sentence, but you just change the parallel to the perpendicular, okay, for the transverse wave. Okay, so this one you have to remember the meaning. We can see they produce a compression and reflection part. So see they produce a compression and reflection part. Okay. Okay, for this one, okay, I will not explain because we already labeled, right? Okay, I already explained just now, okay, in the slide before, okay. So this is the direction of the propagation. This is actually the compression part. This is the reflection part, okay. Right, but the wavelength. So how about the wavelength here? So the wavelength is whether from the compression to compression or reflection to reflection. So this is the symbol of wave, okay, wavelength, okay. So the wavelength is from the compression to the compression, okay. This is called as one wavelength, we call it to the reflection, okay, one wavelength. All right. So this is the direction of propagation. So mean it move from the left to the right, right? Okay. So let's try to answer for this one. I give you time to answer. Done? Can I call anyone to answer for me? C. I would like to call Sharanya. The one very quiet one. Sharanya, what is the answer for C? And for D, I would like to call Rindia. Rindia. Okay, and E, I would like to call Eugene. And F, I would like to call Lakshmi. Okay, Sharanya, longitudinal wave. Okay, so longitudinal wave. Okay, correct. Very good. Rindia, parallel. Okay, it says here the direction of the spring wave is parallel. Okay, good. Okay, so Eugene, Lakshmi, what's the answer for E and F? So the wave that travels along the spring consists of series of what and what? Lakshmi, your F, right? So wavelength, yes. The wavelength is the distance between two successive rarefaction or two successive compression. Okay, correct. From this one, from C to C, we call it one wavelength, or R to R, we call it as one wavelength also. Okay, very good wavelength. Eugene, where are you? Eugene? Progressive. E is progressive, is it? The wave travels along the spring consists of series of progressive and stationary. How come it can be like one moving and at the same time it's not moving? Progressive is a moving, right? It moving, the wave is moving. Okay, but the stationary means the wave is not moving, it just stay there, right? So it cannot be that the same thing as one, okay, because that one is a very different thing. Okay, anyone, are the others, want to try? Saji, for E, maybe you got a different answer. Compression and rarefaction, very good. Okay, so let's see your answer. Parallel, okay, and compression and rarefaction. So it consists of the compression and rarefaction. So it's just a series, right? It keep repeating. Okay. And then the wavelength is the distance between the two successive rarefaction and two successive compressions. From here, we call it as one wavelength. Or sometimes wavelength, we call it lambda. Yeah, lambda is a wavelength actually. Okay, so the next part, okay, number 2. I give you some time to answer. So you have to label a wavelength of the wave. Okay,
Teacher, what's the symbol for wavelength?
this one, lambda.
Okay, teacher.
Okay. Label the wavelength of wave. So you can put 2 successive crests or 2 successive throw. Okay, that is one wavelength. Or sometimes if they give you a graph, right? Okay, sometimes they give you like a graph like this. Okay, so this is actually the transverse wave, right? So this one from here to here, we can call it as one wavelength from crest to crest, or maybe wait, I draw another one. So or here from throw to throw also is another wavelength. Or sometimes you can take 2 semicircle here. 2 semicircle also, this one we call it as a wavelength. Okay, because sometimes they will ask you, okay, which one represent the wavelength. Okay, so whether crest to crest or throw to throw, okay, 2 successive crest or 2 successive throw, or you can take like 2 semicircle here also. This one also we consider is as one wavelength. Okay, so for here, right, you have to label the wavelength. So let's say if I divide this one into half like this, okay, so this one I will answer, okay. So for this one is actually from here to here, right? This is the one wavelength, okay. From here to here, okay. So this is also one wavelength, okay. Or maybe from here, 2 semicircle, right? So 2 semicircle, I put, let's say, from here to here. Okay, so this one is also one wavelength. Okay, if you want to see it clearly, you just refer to my graph here. Okay, from here to here, from here to here, or 2 semicircle. Okay, the one that I shade, okay, the graph here, this is actually equals to one wavelength, right? So can you understand about the wavelength? Okay, because sometimes they give a graph, they ask you to find which one is the wavelength. Okay, but later you will learn there are 2 types of graph. Okay, so that one is later. Okay, so for B, all right, so you have to show the direction. Okay, so the direction, can you give me like maybe from the left to the right or from the right to the left? Okay, so can I call Krisha? Okay, what's the answer for this one?
Right to the left. Wait,
Right,
teacher.
right to the left.
It's the hand diagram, right, teacher? The down
Here. They move here.
left to the right.
Left to the right, right. So you move left to the right, so it means from here to here. So this is the direction of the propagation. Okay, but the direction of the vibration, it move up and down. Okay, so for this one is actually show the direction of the vibration of the color thread. So this one up and down. Okay, it move up and down, but the direction of the propagation, it move from left to the right, right? So for A here, okay, for A weekend, this one is what? The wave produced by the sinking spring is a?
Transverse wave.
Okay, transverse wave, very good. Okay, for B, Janet, the direction of the spring wave is what? Perpendicular? Okay, perpendicular to the direction of the wave movement. Okay, this one. Okay, this one the label here, right? Okay, correct. So the conclusion here. Okay, so the conclusion here. Okay, I give you no because this one is very easy. Okay, Raja. Raja, what is the answer for this one? A longitudinal wave is a wave in which the vibration of the medium is
Parallel.
parallel, okay, to the direction of the propagation of wave. Very good. Okay, Rindia, what is the example of the uh, longitudinal wave? Trisha, what is the example? Sound wave.
Sound wave.
Okay, very good. Sound wave. Okay, so I would like to call Nirupa. Okay, the next one, a transverse wave is a wave in which the vibration of particle in medium is perpendicular. Okay, correct. Okay, Asher, can you give me the example of the transverse wave? What is the example of the transverse wave? What is the example of the transverse wave? Asher? Are you there? Asher? Okay, never mind. I'll call Avinash. Yes. Yeah, sure, Avinash. Microwave. Okay, microwave is an example of what wave? Microwave, radio wave. That is actually the example of what wave? It's under what? Yes, very good. Electromagnetic wave. Okay, so that one is also correct. But if you make this one, the answer is correct. It's electromagnetic wave. So actually, the one that Abhinesh gave, that one is the example of the electromagnetic wave. So under the electromagnetic wave, you got microwave, you got radio wave, you got UV ray, okay, infrared. So that one is all is the example of electromagnetic wave, okay. And also another one, don't forget water wave. Okay, so this is the transverse wave. Okay, so this is the graph. Okay, not the graph, it's actually to show what is the difference between the longitudinal wave and also the transverse wave. Okay. Right. So that's all for now. Okay, I will stop until now. Okay, so we continue later. All right. So if you have any question, you can ask. Okay. So I'm sorry for the technical problem over that the peer deck. So I know now peer deck maybe it's better for do the question like that, answer question. So I see you on next. No, on Saturday. All right. On Saturday we discuss. Okay, and thank you. Okay, take care, everyone. Okay,
Teacher,
bye. Yes.
the previous class video on the pressure and the what they call that, the
Oh, volume,
the
voice
gas
law.
one haven't
Yeah, I
posted.
haven't upload yet.
Okay. Thank you, teacher.
Okay, all right. Thank you. All right. Okay, bye.
Thank you,
Thank you.
teacher.
Okay, stay safe,
Thank you, sir.
everyone. Bye bye.